All right, good morning. So this video is going to be about geometry. And since there is a large section on angles, I believe that we'll probably get through the most of angles today in this video. So I'm aiming for about 2 hours for this video, so that way you know how long it is. I highly encourage you, because there are so many pages in this particular packet, which is about 140 pages. I've made up about 10 copies and they are up at Northview right now. So if you do want one of these packets, I would try to get up there right away. They will be open next week. And then after that, they will be closed for the week of spring break, which is the first week of April. Okay, so I'm going to go ahead and share my screen, and that way we can go ahead and start on the geometry. Okay, so introducing angles. It says here that a line is a path of points that extends in opposite directions. So as you can see over here on the right side, we have our line. And again, typically we use this as, like, let's say a number line. And that's why it has these little arrows on each end, because the numbers keep going. Now, you could have letters on a line also, but like I said, typically you're going to see a number line look like this. Okay, so if I put 0 right in the middle, all right, then what would be to the right of the 0 would be, and I'm going to type this out, positive numbers. Okay, so the numbers will get larger as you go to the right. So that's just a little bit of a taste of what you're going to see when we are working on integers, okay, which is positive and negative numbers. All right, so what I'll do is I'll go ahead and just put a couple numbers here. So we have 1, and going all the way up to 5. And of course, that arrow on the right just means it keeps going. Okay, and these are positive numbers. Now, sometimes when kids are younger, you might see a positive number that is reflected like this. It has a little plus sign in front of it, plus the number. That's a positive 5. As grown-ups, you'll probably see just that number. If you don't see any signs in front of it, that means that that number is a positive number. As you go to the other side, though, I'm going to put a -1 here. I'm going to put a -2 here, 3, 4. And as you go to the left, the numbers actually start getting smaller. So numbers to the left of the 0 are negative, and the numbers get smaller the more you go to the right, or I'm sorry, to the left. Okay, so that's a little taste, like I said, of what numbers, the negative numbers and the positive numbers, look like. Okay, so I would, if you have a chance, write down that information, but you'll definitely be hearing it in the near future again. All right. Now, array is a part of a line. So I'm going to change the color here. Array is part of a line. And array has what we call an endpoint. So over here to the right, here is your endpoint. Okay, and then of course this ray in particular is going to the right, and that arrow again means that the numbers or whatever it is, that line just keeps going. So let's say we have the endpoint A. It could be any number or letter, whatever is assigned to that ray. It doesn't have to go to the right. It could be pointing to the left. It could also be pointing up or down, whatever direction it goes, okay? Now, what we call an angle is formed when you have two rays that meet at a point. So remember, the ray has an endpoint, so the angle is going to have two rays, okay? And it meets together at that endpoint. All right, so let's say, for instance, we have this angle right here. There's a ray. There's a ray. And in between, you're going to see a little arrow on the inside. Now, I'm also going to be showing you that you could have a much larger angle than this, and the arrow could be on the outside of those two rays. Okay, so we'll get to talk about that also. But for now, it says here that the rays that form an angle are called the sides or the legs of an angle. And what that means is this right here. These are called the sides. Spelled that backwards. Or what is known as the legs of the angle. Okay. Also, of course, on this side, you also have this right here. Again, that's the side or the leg of that angle. Now, the point where the rays meet is called the vertex. So we called them an endpoint just a minute ago, all right? And they are sort of an endpoint because the two rays come together, and at the end of that ray, it has an endpoint. But when we specifically start talking about angles, this right here, we're going to refer to this as the vertex. All right, so I'm going to draw a line down to vertex so you can see that right where those two rays meet. Okay, and then the size of an angle depends only on the opening between its sides. So remember how I said you could have a curved line in here. It's kind of like an arrow. This could represent how large this angle is. And I could say, okay, well, this angle looks to be about 40 degrees. Okay. And we'll go over the, how I came up with that in just a few minutes. You could also, though, have an angle that could be much larger, and you want to look out for that curved line with the arrow. Okay. So what if that curved line with the arrow was on the outside? That means that the angle is actually a much bigger angle. And so I'm going to take a guess, and I'm going to say, well, this is maybe about 150-degree angle. It's much, much bigger. Okay, so angles can be small. They can also be very large. So let's take a look at why that is. All right, so as you see in this picture right here, see that little arrow on the inside of that angle? That is a very small angle. That means wherever that little arrow is with the curved arrow is where it's defining the degree, the amount of degree for that angle, okay? When I talk about the degree of an angle, what I'm doing is I'm talking about, okay, we're going off of 360 degrees, okay? So if I was to look at you, I stand up, I make a whole rotation, or I turn my body and I come back around and I look back at you. That is 360 degrees. Think about the earth rotating around the moon, or I'm sorry, the earth rotating around the sun. It has went 360 degrees around the sun. It's made a whole rotation, which the earth is about 365 days. And it equals a year. So the earth is going around the sun, and it takes one whole year. Okay. So let's say, for instance, I have this line right here, and I go all the way around. I just made 360 degrees. Okay. Now, if I took this circle again and I draw this line right here, what if I did this? What if I made just a half of a rotation? A half, I went around this circle just halfway. And we'd say to ourselves, okay, how many degrees would be half of 360 degrees? And of course, that would be 180 degrees. Okay, so when you look at these examples up here on the very top, this one, I'm going to say this is probably about 5 to maybe 10 degrees at the very most. It's a very small angle. You can barely see that angle in between. This one, I'm going to say it's a little bit bigger, maybe about 15, maybe about 15 degrees. Now, this one right here, I'm going to say it's about 105 degrees. Now, why would I say that? Well, here's why. I'm going to draw this circle again. Remember how I said that if you go all the way around, it's 360 degrees, right? And halfway around right here would be 180 because that's half of 360. But what if I do this? What if I took this circle and I divided it into 4 pieces? Oh, that's so bad. Sorry about this. Let's try that again. A little bit nicer, hopefully. It's not even, but I just divided this 360-degree circle into 4 pieces. So if I said, well, how much is this one angle right here? All right. Well, what we could do is we could take 4 and divide it into 360. All right. Just like if we was to figure out what a half of a circle would be, we could go 2 divided into 360. And again, that's 180 degrees. So 4 cannot go into 3, cannot be divided into 3. 4 divided into 36 is 9. 4 times 9 is 36. And of course, 36 minus 36 is 0. Now, I can't just stop right there. I have this other 0 I have to bring down. So when we start some subtraction, we'll do some subtraction before the end of the year, definitely. I'm sure we'll pick it up probably in April or May. But we do have to absolutely bring this 0 down. And then you can say, okay, can 4 be divided into 0? And the answer is no. So what I have to do is I have to put a 0 up here. All right. If you want to check your work and see 4 times 90, it should end up being 360 degrees. So that's how you're going to check your answer when it comes to division, 90 times 4. So what this means is this one arrow, this one angle, sorry, is 90 degrees. And that's a special angle that we're going to talk about in just a minute. But if you go back to this third one, if I was to draw a straight line up from here, this right here would be a 90-degree angle. Now, the reason why I said I'm going to guess it's about 105 because it's more. It's a little slightly more than 90 degrees, right? All right. And so that's why I said I think it's about 105. Now, if we went, remember, if we went halfway around, that's 180. So what that would mean for this right here is if it was anywhere near 180, it would go all the way down here. So we know that, you know what, it's not that big, right? And then let's look at the last one. Here's the last one. Let's say that we start over here and this is our 0 degree. All right. Well, we know that here's our line if we were to do 180 degrees, right? But let's look at our figure again when it comes to dividing it into 4 pieces. If I was to go all the way through 3 of these pieces, think about it, 90, 90 plus 90. So 90 times 3, or you can add it, 90 times 3. Well, 0 times 3 is 0. And 9 times 3 is 27. 27. So that right there, if it was to come all the way straight down, this would be 270 degrees, right? That's your 180. Here's your 90 if you were to go straight up. So think about, what degree do you think that this arrow is? We know it's more than 180. We know it's less than 270 degrees. Well, we could say, could be about, let's see. I'm going to say about 250. If you said around 250, 245, 240, you'd be doing good. All right. So somewhere around that point, I would say that's about it. Okay. Now, some of this is going to be kind of repeated of what I've already said. Notice that the arc, which is the curved with the arrow, is drawn to tell which angle is indicated. So for example, this angle right here might represent, and remember, there's no arrow or curved line drawn yet in this figure right here, but it may represent this if we were to put the little tiny arrow in there. Again, I'd say that's maybe 10, 15 degrees. I'd say maybe 15 degrees. Now, this one is on the outside. So you've got to notice that if it's on the outside, then it's going to be much, much bigger. All right. And look how this, I'm going to draw it just a little bit clearer. It's going almost all the way around. Okay. So we know it's got to be more than 270 degrees, right? Because it's already past. If we were to draw those 4 quarters again, right? It's past this line for 270. In fact, it's almost, let's see, it's almost about right here. So it's close to 360, but there's that little bit of room right here. So if you had to guess, what do you think it would be? We know it's more than 270. It's not quite 360 degrees though. So if we had to take a guess, maybe about 345. So if you're anywhere within that area, 340, 350, something like that, then it's going to be, you're on track. Okay. Now notice also that the size of the angle is not changed when the angle is turned or when the lengths of the sides are changed. So basically, this first example, all 3 of these right here, notice that the arrows, the size of the angle does not change. We just kind of tilted our angle down here. Okay, so it's still about 10 to 15 degrees. We tilted it kind of upward, but it still didn't change it. All right, and then we turned it backwards. okay? And it still didn't change it. In fact, I could try to turn this upside down. Hopefully I'm getting kind of close to how the size is. And that still would not change the size of the arrow or the degrees, sorry, the degree of the angle. Now the bottom part down here is basically just saying when you change the length of one or both of the sides, remember they called them sides or legs of an angle, that it does not change the side also. So if we're going off of, let's say 10, 15 degrees again, all right, see how small it is on the inside. This one right here, they're making one of the sides slightly longer. The other one's pretty short. This one right here, vice versa. The one side on the bottom is much longer and it's stretched out. The one on the top is shorter. Now the third one, they have stretched both of the legs or both of the sides out, but it still remains to be the same degree angle. All right, so I want you to take a pause on this video right now and kind of reflect on your notes and what you have learned. All right, if you need to, you can even go back and review the pages of what, the page that we've already mentioned. Okay, so go ahead and pause it if you need a break. All right, so here's some practice right here, and it says to circle the largest angle in each group of the three angles below. So you're looking for not the size of the legs, you're looking for the arrow that's curved. Is it on the inside? Is it on the outside? Remember, if it's on the outside, that means it's going to be a much larger angle. So you need to circle the largest angle in each group. So as we look at number one, take a look at that. Which one is bigger? Which one is the larger angle? All right, so if you said C, you would be correct because look, this is almost a 360-degree angle. I would say it might have 5 degrees or maybe even just 2 degrees in between this point. So if you wanted to say like 355, 358, you know it's less than 360, okay? I want you to take a moment and look at number 2. You can pause your video if you need to. All right, if you look at D, again, the arrow's on the inside. That means it's going to be a very small angle. E, it's slightly a little bit bigger than D. But F, do you remember how many degrees this would be? This would be 90-degree angle. All right, so it is the largest angle out of all 3. All right, let's go down to number 3. Pause your video if you need to. Okay, if you notice that G is yet another small angle, then you'd be right. So we would need to go between, looks to be L and H. Which one is the largest? Well, on L, it sort of looks like if we would extend it straight, this is not good. Don't want it to be real sloppy when I draw this. I need one of those kind of nice projectors or a ruler or something. If you was to go like this, that would be about 90 degrees right there, right? So we know it's about probably 50 to 60-degree angle, right? Okay, so if you look at the other one though, H looks much larger. And if you was to stretch this leg or side out, this would be 180 degrees. So remember, we said this one has to be less than 90 because we can clearly see that, right? This one, it's not a whole 180 degree, okay? But it is more than 90. So if I had to guess, maybe 105, 110, 115. All right. So H would be your largest angle. All right. So you can finish the other three on your own. Now this right here, in each group of three angles, circle the two equal angles. So I want you to go ahead and take a moment, and I want you to go ahead and do 7, 8, 9, and 10 right now. So go ahead and pause your video. Okay, so on number 7, if you chose A and B, I know these are really close. They look almost the same, but A and B are equal angles. Now C is just a little bit smaller, okay? Now number 8, when we look at this for number 8, we have D and E. Those are equivalent or equal angles, okay? It looks to be, okay, if I extend this arm, that would be 180 degrees right there. We know that it's more than 90 degrees, but it's less than 180. It kind of looks like it's almost in between 90 and 180. So let's say this is around 140, 145, all right? And this is the same, okay? But this right here is slightly different. It is a little bit bigger, actually, all right? Number 9, the two angles that are exactly the same are going to be G and I. And if you look at it, they are both 90-degree angles. They're just turned differently. But if you look at this one for H, we have, think about this, divide it into 4 pieces again. It's starting all the way up here. Let's see. Nope. It's starting all the way right here. There's 90. There's 180. And there's 270. So this one is 270 degrees. The others are 90-degree angles because look, this one is on the outside. So it's going through 3 of these 90-degree angles. And remember, 90 times 3 is 270. All right, for number 10, your answer is going to be J and M. Now, if you look at K, it's a little bit smaller than J and M. Okay, let's go ahead and move on to the next page. And we're going to talk about measuring an angle, which I've already kind of mentioned some of this, okay? As you've seen, the size of an angle depends only on the opening between its sides. This opening is measured in units called degrees. Now, the symbol for degrees is, of course, that little tiny O that's kind of in the upper right-hand corner of a number, just like our oven has a degrees. Like if we want to turn our oven onto 225 degrees, we make that little tiny symbol, right? So if we said 45 degrees, it would be written like this. Okay, so a larger angle has a wider opening with more degrees than a smaller angle. So degrees can be thought of as parts of a circle. So again, here is a whole circle down here, right? We divided it into 360 degrees. And so as you can see, 0 is starting right here. And by the time you go all the way around and back to where it is, that made a 360-degree turn. All right. So another way to look at this is if you want to, if you were to count like 1 degree, well, we could write it 1 degree, just like they have it right here. This would be something like 1 degree. I mean, it's just pretty much touching. You can very, very slightly, ever so much, see that little tiny separation, but there's not much. So that would be 1 degree. Now, if we were to write this in a fraction, well, how many parts do we have right here? We have 360 degrees or 360 parts, and we just finished up our fractions. So if we were to take 1 degree out of 360 degree, we would write it in a fraction like this. Okay. Now, if you say, okay, well, what if I have 80 degrees right here? And so if I connected the dots, and put the little arrow in the middle and draw it, it would look like that for 80 degrees. Okay. What I would do is if I wanted to write it in a fraction, I would put 80 over all of the parts, which in this circle is 360. Now, typically, if you have something like this, they would expect you to simplify. Okay, so here's the thing. You can go about this a couple different ways. You can go ahead and pick a number that you think that will go into 80 and 360. You could pick 2, it could be 4, it could be 5, it could be 10. It may even be 40. All right. You can't do 80, and here's why. 80 can be divided into 80, but 80 cannot be divided into 360, because if you go 80 times 4, that's 320. Let's see, 80 times 4. Yeah, that's 320. So you can't pick 80. Let's choose 10. Let's see what 10 would look like. All right, so 10 divided into 80 would go in 8 times. 10 divided into 360 would be 36. And so from there, we would have to reduce this or simplify this number again. So let's choose 4. 4 divided into 8 is 2. 4 divided into 36 is 9. So if you did have 80 degrees out of 360 degrees, if you were to go ahead and simplify it, you would end up with 2/9. All right. Now, a faster way, a really fast way that you could do this is you could just go ahead, and when you have a pair of zeros on the end of these larger numbers, for every pair of zeros, you can just slash them out. And that's some way that you could reduce very, very quickly. So remember, you have to have a pair of zeros. If you was to have, let's say, 80 over 3,600, like this, you would only be able to take out 1 pair of zeros, right? The only way you could take out this 0 is if maybe you had 800 over 3,600. All right, so now we're down to 836. Again, we're going to take 4 and divide it into 8. And of course, we came up with 2. And 4 divided into 36 was 9. So like I said, you can do it the slower way, where you have to simplify it maybe more than twice. Okay, and you may have to keep going. These are even numbers. You can tell at the end of them that they're both even, so you know that 2 can go into them. Okay, so let's go on down. And it says here that one side of the angle can be placed along the 0 degree line. And what they're talking about is right here. Typically, most of your angles start to the right. Okay, they point to the right. All right. Now we're going to find out when we're looking on the next page about protractors that the 0 degrees could be backwards. It could be flipped and the 0 degree could be on the left side. Okay. So it just depends. The point where the second side crosses the circle shows the number of degrees and the angle. So again, if you were to choose, go here, see if I can get it right on the line, and you were to put the curved arrow right in here, we would know that would be 10 degrees for that angle. If you look at this example 1 down here to the right, says what is the size of the angle at the right? Well, as you can see, it starts over here with 0 degrees on the right, and this goes all the way up to 80 degrees. So there's your answer. That one was pretty much easy, very easy. All right, example number 2 though. You have a pie and it's cut into 8 pieces. What angle do the straight sides of each piece make? All right, so remember that when we had the circle, right, the whole circle here, and we divided it into 2 pieces. Well, we took 2 and divided it into 360. If we had 4 pieces, we would then take 4 and divide it into 360 degrees, right? But if you've got 8 pieces, just like in the above example, what we're going to do is we're going to take 8 and we're going to divide it into 360 degrees. And once you do that, I want to go ahead and show anyone that is, there are a lot of students that are not sure how to use division, or you might struggle with it. So we're going to do a little bit here. We would have 8 divided into 45. Well, 8 cannot go into 4, but 8 can go into 45 4 times. Okay. Oh, you know what? I'm wrong. I messed this one up. I don't even know what I'm thinking. 45 is the answer. Duh. All right. You're going to take 8 divided into 360. That's why it wasn't working. All right. 8 cannot go into 3. 8 can go into 36 4 times though. So 8 times 4 is 32. So you bring that down here. Now you're going to take your whole 36 and you're going to take away what you already figured. Okay, so that will make 4. And you can't stop right there. That's not your answer. 4 is not the answer. You got to bring the 0 down also. So now you have 8 divided into 40, and that makes 5. Of course, 8 times 5 is 40, and you have nothing left over. All right, so that would be 45 degrees. All right, so here is your questions that you're going to be working on. Go ahead and do 1, 2, and 3. That should be really easy. Now, as for 4 through 8, here's what I want you to do. You're going to be able to do 2 of these right now. Okay, you may even be able to do all of them right now, but I'm going to show you the 2 that I know you should be able to do. All right, so number 7, this is the figure for number 7, and you should know, because I've already said it a few times, how many degrees is this? So this angle right here is 180 degrees. So this would be A. All right, it's half of a circle. So your answer is going to be A. Now for number 5, here is your angle right here. We've already talked about this angle. In fact, these 2 problems that we're doing right now are very, very common angles. They're almost famous, okay? They go by another name too. But yeah, that one's 180 degrees. And number 5 we said was, well, that's 1/4 of a circle, right? So if you take 4 and divide it into 360, you would get 90 degrees. So this is a 90-degree angle. So down here at the bottom right, you're going to see where it says E, 90 degrees. Now, as for the other ones, now that you have these two marked, it should be a little bit easier to do numbers 4, 6, and 8. But if you would like to wait until we do the next couple pages and come back and do this page, that's fine, okay? Because you're going to learn a lot more about what these angles would look like, okay? Now, these 4 questions right here, they go off of, again, if you take so many parts of a full circle, all right, then you're just going to take that amount of parts and divide it into 360. So like number 9, let's say you have 9 children and you have 1 whole pie. Now, no, you know what? I messed up on that. You have 12 children. Okay, you have 12 children, and each of those children want an equal piece. My goodness, no child is going to take a bigger or smaller piece than another child, right? They got to be exact. So you might want to get out your ruler when it comes to measuring this poor little pie that's going to be chopped up into 12 pieces. But how would you figure out what each angle would be? Well, you could write it like this: 360 degrees over 12. And what that essentially means is 12 divided into 360 degrees. So go ahead and take a few seconds and figure out 12 divided into 360. Well, 12 goes into 36 3 whole times. And 12 times 3 is 36. So you have nothing left over, but you cannot leave it right at 3. That would not be the answer. Again, you have to carry down each of these numbers that are over here. So if you even had another 0, you would have to carry it down. And so then you would say, well, 12 cannot go into 0, so I'm going to put a 0. All right. Again, if you had another 0, you'd have to carry it down. 12 can't go into 0, and then put another 0 here, and you'd have 300. But we're going to go ahead and stop right here. So if you were to divide 1 whole pie, that's 360 degrees, and divide it by 12, your answer would be 30 degrees. Now, 11 and 12, we've already done that. They're just writing it into a question form. 10, you've got 9 pieces, 9 equal pieces, okay? And you got a circular piece of loaf bread. All right, sounds very delicious. So you're going to do it the same way that you did number 9, but you have 9 pieces here. So again, you're going to take it and divide it into 360 degrees. All right, so if you want to go ahead and pause the video and do those 3 problems, go ahead and do that. All right, so you can go ahead and check your work, check your answers in the back of the packet or the very bottom of the packet. Now we're going to talk about 5 different types of angles, and these are the infamous 5 types of angles, okay? So the first one that I like to cover, because I kind of like to go out of order from what the book is I want to talk about that 90-degree angle that we've already talked about. All right. Another name for it is the right angle. Okay. And a right angle measures exactly 90 degrees. Okay. Now, when you have a right angle, not only does it look like two sides or two legs that are, perfectly put together, okay? And it looks like an L. It also typically is represented by this little small square at its vertex. So you see this little tiny square, many times a right angle will have that square. Okay, so if you just see this picture right here, you should be able to tell instantly that it's a right angle. Okay, and again, it could be typically it looks like this, but it also could be backwards like this. Let's see, that one's not backwards, but it could be turned around like this. It could be upside down. It could be tilted up. Many different ways, however you want to do it. It's still a 90-degree angle as long as you have those two sides perfectly put together at the vertex. And most of the time it will have that square. All right, so that is a 90-degree right angle. Okay, the next one that I'm going to is going to be that 180-degree angle. I said that was another infamous one. I think these two out of the 5 are probably the easiest to remember because you're going to see them the most often. Okay, and the 180-degree angle is called a straight angle. Now, if you look at it, this is just a straight line, so that should be pretty easy to remember. And we said that it's half of a circle, and it is exactly 180 degrees. So that would be a straight angle. Now, you could also, again, these angles could be different ways. It could be up and down, straight up and down. And again, that is a 180-degree angle, and it is a straight angle. All right. I'm also going to tell you that when it comes to the right angle, okay, if you look around and you're building your home, a lot of furniture in your house, you could notice that the ceiling, the walls, maybe a table in front of you is going to be 90-degree angles. So typically when they build most houses, they are basing it off of a 90-degree angle. Okay. All right. So that leaves us 3 more angles, 3 more types of angles to cover. Now, the third type right here is called an acute angle. I always think, oh, it's such a cute little angle. All right. I'm going to stop the video for just a moment. Okay, so I took just a moment break, so it should have seemed like just a couple seconds to you. All right, so our third type of angle that we're going to be talking about today is called the acute angle. And again, it's smaller, so I always kind of say, oh, that's such a cute little angle. Now, what this is when you have an acute angle is it's going to measure greater than 0 degrees, but it has to be less than 90 degrees. Because remember, if it's exactly 90 degrees, it would then be a right angle. So anywhere between more than 0, less than 90 is called an acute angle. All right. So if you had, let's say, 18 degrees, that's going to be an acute angle. If you have 72 degrees, that is an acute angle. If you even have 1 degree, that's an acute angle. Let's say you have 89 degrees. All right, 89 degrees, that is also considered an acute angle. So they're the smaller ones, okay? Less than 90 degrees. All right, now the fourth type of angle we're going to talk about is called the obtuse. Typically when I think of obtuse, it is a bigger angle. I typically think about trying to open your mouth as big as you can when you go to the dentist. You know, the dentist will lean your chair back as much as they can, typically more than 90 degrees. And most of the time, they do not put you flat on your back, so you would not be 180 degrees. So an obtuse angle would be, it's going to measure greater than 90 degrees, but it's less than 180 degrees. All right. So it's going to be somewhere after the 90, less than 180. All right. So remember, 180 degrees is called a straight angle. So it has to be greater than 90, less than 180. So we could even have 91 degrees. In fact, if you want to say you have 90.5 degrees, okay, that would still be considered an obtuse angle. All right. You could have 179 degrees, and that would be an obtuse angle. So, you know, whatever kind of association that you want to put with these different angles, that works when we associate it with something else. Again, I typically think of the dentist office, maybe trying to either sit back inside your seat or opening your mouth as big as you can. Okay, so that is obtuse, obtuse. Now, the last fifth type of angle that we're going to look at is called the reflex angle. Now, these are the big ones. These are the biggest angles that you can have. A reflex angle measures greater than 180 degrees, but it has to be less than 360 degrees. So that's why I said any of these large ones, anywhere where it's more than 180, it goes all the way around. Right here, remember, 270 degrees is 3/4 of a circle, right? And then finishes all the way to almost 360 degrees. So if you say you have 181 degrees, you know, it's just a tiny bit over the 180. Say you have 359 degrees. Now that, again, that is going to be what the 1 degree looked like, but it's going to be on the outside. The circle and the arrow will be on the outside of that. So 359 degrees. Here's what 214 degrees looks like. It looks like it's more than 180. Whoops, it's more than 180, because if it was 180, it would go straight out here. We know that it's less than 270. And again, it looks like it's somewhere between the 180 and the 270. So let's see, 270, that would be about right. All right. And then, of course, over here is your 340 degree angle. And of course, it is on the outside. So we can tell that that is a large angle. Okay. All right. Typically, you know, when I think of a reflex angle, if I was to put my fist and I stretched my right arm straight out, okay, and I did the same with my left fist and I put it straight out that way, okay, so I've got my arms kind of straight and even right here. If I dropped my left arm just a tiny bit, that would be a reflex angle. If I'm sitting here and I'm trying to reach all the way around and I'm trying to flex my back or flex my arms, that also would be a reflex angle, because you're trying to match your one hand and try to get it behind your back to match with the other one. But, you know, it's hard to touch those two hands together. All right. Unless you're maybe a kid who's very flexible. Right. So that would be a reflex angle. All right. So as you look at these, I want you to go ahead and do 1 through 6 and pause the video. You're going to tell me whether it's an acute, a right, obtuse, straight, or reflex. So go ahead and pause the video. All right, so your answers here for number 1, and actually I'm going to go ahead and type this out so you can see it. The first one is going to be an acute angle. The reason why is that it is more than 0 degrees, but it is less than 90 degrees. So that makes 28 degrees an acute angle. Number 2 is a right angle. It is a 90-degree angle. Also, it has that little square there that's going to give you that indication that it is a right angle. Number 3, 150 degrees, that is an obtuse angle. Oop, if I could spell it. An obtuse angle is more than 90 degrees, but it is less than 180 degrees. Number 4, that one should be very easy also. This one is called a straight angle. Hey, it's a straight line, and a straight angle is half of a circle. It is 180 degrees. Number 5, 310 degrees. We can tell not just by the number, but we can tell by the circle on the outside with the arrow that this is going to be a very large angle. So if it's past 180 degrees and it's less than 360, it is called a reflex angle. And then lastly, 88 degrees. This is actually an acute angle. All right. An acute angle is more than 0 degrees, but it's less than 90 degrees. All right, so that makes it, oh, that's such a cute little angle. All right, so the rest of this page right here, you can do on your own. It's really easy. And now that we know the 5 types of angles, I would say definitely go back at this point right now and finish 4 through 8. So you should be able to find, you know, by knocking off the 180 degrees, which is A, and then knocking off 90 degrees, which is E, that leaves you with B, C, and D. So those are very definitive, different kind of numbers right here. 35 degrees is a lot smaller of an angle, and you should be able to tell it just by looking between 4, 6, and 8 between those numbers. Okay, look at C. C is a very large angle at 210 degrees. All right. Okay, next page. We're going to talk about labeling angles. Now, labeling angles is, I think it's pretty good. I think it's pretty easy. You know, when you start looking at it, it looks like it's a bunch of mumbo jumbo kind of directions, but I'm going to break it down. I think it's pretty easy. When you label an angle, there are 2 different ways that you can label an angle. First, it says an angle is often labeled with 3 letters. Okay, so if we look at this one right here for number 1 on the left, okay, here's our angle. The vertex right here is the letter, or it could be a number, but the letter that's in the middle is where the vertex is. So if you have 3 letters, you're going to use this little symbol. It almost looks like a greater than sign, okay? Or I'm sorry, a lesser than sign. It's kind of tilted up. So when you look at it right here, it's kind of tilted up just a tiny bit, all right? And that little sign here means, and it represents the word angle. All right, so every time you draw that little symbol, you would say the word angle. So what we could do is we could say angle A, B, C. But there's another way that we could actually name this angle also, because we do have 3 letters. We could say angle C, B, A. So we could turn it around. Just make sure whatever you do is where that vertex is, that letter has to stay in the middle. All right, so you can go A, B, C, or C, B, A. You cannot say like B, A, C, or B, C, A. You can't do that. That's out of order. So you always have to make sure the vertex letter is in the middle. Okay. Let's see. Okay, number 2, an angle can also be labeled with a vertex letter or a vertex number only. So this would be right here. Remember where the 2 rays come together is the vertex, okay? And you could see where the letter B is on the outside, but sometimes you could also have the letter on the inside, okay? So just be prepared for either one. What you would do when you label this angle right here is you're going to label it like this. Draw the little symbol for the angle sign and then put B. So you're going to call it angle B. All right. Now, also with the number, that number 3 on the vertex could be on the outside or it could be on the inside. But at the end of the day, you're going to write your little symbol for angle and you're going to write a 3 or whatever number it is right beside of it. So this would be called angle 3. Okay. So let's get a little practice with this. Let's see. Number 1. We have the angle right here. And we can go by 2 different names. Now, when you do this, you always need to start out with your symbol on all of these, okay? So this for number 1 would be angle CDE because we need that D to be in the middle. So we're right, angle CDE. But what's the other answer? How could I put it for a second answer? Think about that. You could write it angle EDC. So we're just turning it around, but again, we need this letter D to be in the middle because it's the vertex. Okay. Now, number 3 should be pretty easy. You see an angle, it only has 1 letter. So we're going to start off by putting angle, the symbol for angle, and it's going to be called angle F. And that's it. All right. Now let's do number 5. Again, we write our symbol for the word angle. And this one is a number 5. So we're just going to put angle 5. And that's all there is to it. All right. So go ahead and do 2, 4, and 6 on your own for homework. And we'll go on down to the next page. If you need a little break, go ahead and pause the screen. That's fine. This is a kind of a 2-hour video. So I'm going a little faster than normal. And if you have to stop and kind of review it again, that's fine. Okay, right now we're going to be looking at information about the protractor. Now, the protractor, they're usually always sold in the store. They come in different colors, clear. I've seen them in kind of a bright pink, green, blue, typically those colors right there. But typically your protractor, It should be around maybe $1. They used to be really cheap. Now with prices going up on everything, they could be maybe $2 or $3 for all I know. Typically, I would think that dollar stores would carry them. You could find them at definitely Target, Meijer, Walmart, and you could also pick them up at office stores. Okay. But a protractor is, it has this shape. It's flat on the bottom and it goes up like this. All right. Typically, they're always plastic, hard plastic. They're kind of flexible, but you don't want to bend it too hard, right? And then it typically has a little hole in the middle that kind of looks like a circular window. All right. There are some protractors that are more expensive that would have kind of like a little metal clip or something that would pull down or something like that. But I typically would get just a regular cheap protractor. Okay. And it says here that a protractor is a tool used for measuring and drawing angles. So the most commonly used protractor is shaped like a half circle and can measure angles up to 180 degrees. So if you were trying to draw a full circle, then go ahead and put it down, draw around the edge, then stop, turn it upside down, and then finish it. So you would have a perfect circle. Okay. Now, for the example here on the right, it says that you are seeing a protractor that's measuring angle RST at the right. So again, if we were to label this, we would say angle RST. But again, we could also say angle TSR. All right. And as you see, this S is on the vertex. That means it's in the middle of the bottom. Because if you draw a line straight up, you're going to hit that 90 degrees. Okay, so the line or the vertex for S is right smack in the middle of the bottom. Okay, now as you can see, this T starts on over here to the right. And I'd say typically a lot of your angles do face to the right. Okay, and then of course the other leg is going up to where we have the letter R. Now, if I was to try to make this bigger, I don't know if it's going to make it blurry or not, but I'm going to try and hopefully you can see it. The one thing about protractors that you do need to remember is it depends on where the bottom line starts. Okay, so where this T would start, we've got to look, is it starting on the right side or is it starting on the left side? Okay, this one is starting on the right side. So again, it's going to be hard to tell, but this is 0 degrees. And you have numbers on the inside. So I'm going to kind of draw a line along this. You have numbers on the inside. And as they go from the right all the way to the left, they are getting bigger. Okay. And then by the time they hit the left side here on the inside, it's 180 degrees. So let's see if I can get this erased. So again, if I was to draw the line straight up from the 0 degrees on the inside, and let's say that the line ended right here, the letter R was right here, we'd be able to tell that that's a 90-degree angle just by even glancing at it. You know, you could draw a little square right here and it is a perfect 90-degree angle. But R is actually falling in a different place on this, okay? So I'm going to bring it down just a little bit. And again, this is starting over to the right. So you are going to be looking at the inside numbers. If you notice, it's a little blurry. Here is 60 degrees right here. Here is 70 degrees right here. All right. This angle is falling right smack in between the 60 and the 70. So we would want to say that this angle is 65 degrees. Now, another backup system, because like I said, this is going to flip-flop real soon when we start looking at this. You're going to have to be prepared for the bottom leg or side, whether it's facing the right or facing the left. Okay, you need to also have a backup system, right? If you look at this angle, okay, and you said, well, I'm not really sure what the degrees are, because there's two different degrees here. There's the one on the inside that's 65 degrees. There's the one on the outside. And I know it's hard to see these two numbers right here, but this appears to be, this is 110 on the outside. And this one right here is, let's see, 70, 60, 50, 40, 30, 20. This is 100 degrees right here. All right. And again, it's falling right in between the 100 and the 110. So we would say, okay, well, it's falling on the 105, the 105. So here's the thing. Is this angle 65 degrees or is it 105 degrees? Well, our backup way to tell is look at the angle. It is a little angle, right? It's not a huge angle. It's not an obtuse angle. It's an acute angle because it's such a cute little angle. All right. So if you had to decide between 105 degrees, which is an obtuse angle, because you know that obtuse angles are more than 90, but less than 180. And you know that acute angles are more than 0, but less than 90. You are looking at an acute angle. So it's going to be the 65 degrees. Okay. Now, again, if this was pointing to the left, all right, then when you start at 0, you are going to be looking at the outside numbers. Okay. So let's say, for instance, that this is now our new arrow. All right. It starts off over here to the left. We are now looking at the outside numbers. So here's 0. As you go all the way up to the outside numbers, we're going to go all the way over to where the R is. And again, this one is 110 right here. This one is 100 degrees right here. And we said it's falling right in the middle, which makes it 105 degrees. Okay. So this is kind of like the dentist leaning your chair all the way back, or you opening your mouth really wide. This is a wider, larger angle. So we can tell by just looking at it, this is an obtuse. And again, an obtuse is more than 90, less than 180 degrees. All right, so let's get some more practice here. All right, now they put an M, the letter M, in front of the angle. And this is just kind of read as the measure of. I don't really pay too much attention to the M. I'm looking for right here, the two questions that they are asking you is how many degrees is the angle and what type of angle is it? Now, I think sometimes it's actually easier to say what the type of angle is first and then go back and figure out the degrees. Okay, so for number one, it's going to start on the right side of the protractor. So we know that if it's starting on the right side for 0, we're looking at the inside numbers, right? 0 degrees, we're looking at the inside. But as we follow this right here, we can see that here's 10 degrees, here's 20 degrees, and then over here is 40 degrees. So right on the line for 30 degrees, right here is where this falls. Now, you might say, well, how do I know it's 30 degree? What if it's the outside number? Well, as we go here, 90 right here, 100, 110, 120, 130, 140, 150. So your choice is either 30 degrees or 150 degrees. Now, look at what type it is just by looking at it or looking at those numbers. Which one is it? Isn't it acute? Is it acute or is it an obtuse? Remember, it's a cute little angle. So this is going to have to be the 30 degrees. It is a small angle, and we're going to call it an acute angle. So it's 30 degrees, and it's called an acute angle. All right, let's go to the next problem. Let's see. Let's look at this one. All right, so the line is starting at the right again. As you can see, this is kind of leaning far, far back on the left side of the protractor, right? So just by looking at it, I know it's not quite a straight angle at 180 degrees, but I know that it's almost 180 degrees. So I know I'm looking at an obtuse angle. So OBTUSE. All right, got a good guess that it's an obtuse. Here is the 0 degrees. We are starting over to the right, so we're looking at the inside numbers. Okay, so we see that here's 150, here's 170, and it's right in between 150 and 170. So we can clearly see that it's going to be 160 degrees. Now, if you forget and you think, well, wait a minute, you know, I always do that when it's been a long time since I've been doing protractors and angles and stuff. I'm like, okay, wait a minute, which one is it, the outside or the inside? Look at the type of angle it is. You think it's a huge angle because it is a bigger angle. It's leaning all the way back. Here is 0 degrees over here, 10 degrees. This is on the 20-degree line. So do you think that this is 20 degrees or do you think it's 160 degree? Well, if you said it's an obtuse, then you know that it's more than 90, less than 180, right? So it's got to be 160 degrees, and it is an obtuse. Now, I would say that number 2 and 4 is very easy. Remember, those are the most common ones, so you should be fine with those two for number 2 and 4. Let's go on down. And I'm actually going to skip this top part. You can read it on your own, but what I'm going to do is I'm just going to go down here and explain it, okay? So let's see. I want to do both of these just in case. So what you're doing here is you're going to tell what type of angle you have and pick A, B, C, D, or E. And then you're also going to tell what is the degree, what is the measure of this angle. Well, just by looking at it, I can tell you it's a little angle, right? It's an acute little angle. We know that an acute angle is more than 0, less than 90, right? So let's go ahead and blow this up a little larger, as large as we can get it. This is starting at the right. And so it's starting at 0 degrees, and it's going to be starting right on the inside numbers. So as we go up, 10, 20, 30, 40, and there's 50. Now that sounds about right for being an acute angle, right? But again, what if you're not sure? Look at the outside numbers. Here's 90, there's 100, 110, 120, 130. So your choices are either 130 degrees or 50 degrees. And we've already said it's an acute angle because it is small. It's smaller than a right angle, right? So we're going to go with the 50 degrees. All right, one more of this type. Okay, now this one is facing backwards, okay? We're still wanting to know what type of angle it is, and we're wanting to know what is the measure of degrees. Now, just by eyeing this, we can see that it's pointing to the left, right? So this is always going to be 0 down at the bottom. And we'll highlight the other side, or you might call it a leg. And this is R. All right. It's turned around backwards, but you can see that it's a small angle. All right. It's less than 90 degrees. So it has to be an acute angle. All right. So if we go off of that guess right now, let's blow this picture up even larger so you can see what this would look like. Now, when it's facing to the left, you're starting with 0 degrees, but you're going to be on the outside numbers. All right. Again, here's 10, 20, 30, 40. It skips over here to 50. So look at this. It comes right in between 40 and 50. So what would that be? It's halfway between 40 and 50. So that would have to be 45 degrees. And we guess that it's an acute angle, and we're right. It is 45 degrees. Now, if you're not sure which number to look for, again, here's your inside numbers: 180, 170, 160, 150, 140, 130. So it's in between 130 and 140, which would make it 135. So you would say, okay, well, is this angle, it looks to be an acute angle. So is it 45 degrees or is it 135 degrees? And we know that it is 45 degrees because that's what matches an acute angle. All right. Down to the next page. Number 7, very, very simple. Number 8, very simple. Number 9, it's starting where it says letter Z. It's starting over to the right. So remember that. You're going to, if it starts to the right, you're looking at the inside numbers. Number 10, let's do this one together. Just by eyeing this, what type of angle is this? Well, it starts over here to the left where the C is. All right, so I know my zero's over here. And then my other leg or my other side is leaning really far back. And then here's your letter E. So it looks like it's almost a straight angle. I mean, it looks like it's leaning really far back. We know it's not a little angle because look at the arrow, the curved arrow. We know it's a larger angle. So we know that this has to be an obtuse angle. All right, let's make sure that our theory is correct. Now, if it's starting on the left, you're going to go with the outside numbers. So 0 degrees, here's the 90. Let's skip over here. Here's 120, 130, 140, 150, 160. So that sounds right. It's 160. It's almost leaning all the way back straight. Here's the 180, but it's not all the way back, right? So it's an obtuse 160-degree angle. All right. Now, this section right here, you could skip it if you want to. It's all up to you. I think it's more important that you do the others, okay? But if you just want some practice, go ahead and do this. So that's page 20 and 21. Now, let's see. I'm actually gonna do a couple of these right here. All right. Number 3. It says that you're going to draw an angle of 40 degrees that opens clockwise, okay? So this is number 3. All right, so that means what we're gonna do is we're gonna start over here to the left where the 0 is. All right, and we're gonna go up to where the 40 degrees is. So if we're starting over to the left, all right, we're looking at the outside numbers. So when I draw my other leg, I'm gonna draw it this way right here. It's not exactly on the 40, but there we go. Plus, we know that 40 degrees is an acute angle. As we glance at this, yep, we got an acute angle, looks good. Now, we would ask ourselves, a 40-degree angle is equal to what of a complete circle? So a complete circle is 360 degrees. So what you're going to do is you're going to place your 40 degrees on top of this fraction. All right. Now, you can do 2, 4, you can do 5, 10 to go into both of these numbers and simplify them. I'm going to do it the fast way. I've got a pair of zeros, so I'm going to get rid of them. Now I've got myself down to 4 over 36. Now, pick one number that can be divided equally into 4 and 36. It could be 2. There's one number that's higher than 2, though, and that would be 4. So take 4 and divide it into 4, and take 4 divided into 36. And which of these answers would you get? All right, so 4 divided into 4 is 1. 4 divided into 36 is 9. So your actual answer for this problem would be C. It'd be 1/9. And that's how you would do that question right there. Okay. All right, next one below. Okay, number 4. It says that you're going to draw a 125-degree angle that opens counterclockwise. So what this means is we're going to start off to the right. Right? And the 0, we're looking at the inside number of 0. So that's where we're starting. And we need to go all the way with our other leg to 125 degrees. Now remember, we're going on the inside numbers. So if we go all the way around past the 90 degree, there's 100 degree, there's 110, 120, 130. So we know that 125 is going to come right in between 130 and 120. So we're going to take our other leg and draw it right smack in the middle between 120 and 130. And there you go. All right. And of course, we're putting the arrow because this is counterclockwise. The arrow is going that way. So that's how I can kind of, I'm not that great at saying, okay, clockwise, counterclockwise, but I can usually look at this arrow that they're giving. All right. And then I can say, okay, if it's pointing that way, then I need to start on the right. If it's going that way, I need to start on the left. Okay. Now, an angle measuring 125 degrees is blank than a right angle. All right. So think about, what is a right angle? How much is it? Well, a right angle is 90 degrees. So first off, which one is bigger, 125 or 90? Well, of course, 125 is bigger. So you would say an angle measuring 125 degrees is bigger than a right angle. So all of these are larger. All of the answers that say larger are prospective correct answers. The other ones, A and E, are now out. Now, all we got to do is some simple multiplication. 125 degrees minus 90 degrees. And then you can get your answer. Well, 5 minus 0 is 5. 12 minus 9 is 30 or 3. So you have 35 degrees larger. So an angle measuring 125 degrees is 35 degrees larger than a right angle. Okay. Oops. All right, you can do number 5 on your own. And I want you to go ahead and take a pause, take a little break, and we're going to be starting on pairs of angles. Pairs of angles in just a moment. All right, so I took just a moment break, and so we're going to get back into more angles. We only have another 8 pages or so to go of angles, so we'll see how far we can get with this. And then the next section after this is actually kind of where we get into triangles. And then, of course, after that is going to be sum of angles. So, a little bit more angles, it's kind of a lengthy area. But then after that, we'll finally start getting into like a different form of geometry with perimeter and area and volume. Okay, so now we're going to be looking at 3 types of pairs of angles. So we did 5 types of angles. We did the acute, we did the right, obtuse, straight, and the reflex, right? So now we have 3 types of pairs of angles. And so the first type that we're going to be looking at is called the complementary angles. The second one is called the supplementary angles. And the last one is going to be the vertical angles. Now, I think that the complementary and the supplementary is pretty easy. Vertical, it's not too bad. It just takes a little more explaining. But if if you know your right angle as opposed to your straight angle, you should be pretty good on this. So a complementary angle is when you have angles whose sum is 90 degrees. And by sum, I mean to add. All right, so you're going to be adding one angle to another angle, and its sum, it is equal typically when we see that word is, it means equal. And it's equal to 90 degrees. So if we took, let's say for instance, we had this right angle, because that is 90 degrees. So whenever you have a complementary angle, it will always be a 90-degree angle. Let's say I cut this into two pieces, right? I'm going to have angle A here, and I'm going to have angle B over here. And what if I said that angle A is 35 degrees? What I want to know is how many degrees does angle B measure? So what you would do, knowing that this is a 90-degree right angle, all right, you would take 90 and you would subtract what you do know the other one is, which the other one is 35 degrees. So you're just going to take 90 minus 35. So go ahead and figure that out. Take a moment. Okay, 0 minus 5, can't do it, right? So we're gonna have to borrow. What I'm gonna do is I'm gonna borrow from the 9 and make it an 8. And I'm gonna put a 1 in front of the 0 to make this a 10 now. So 10 minus 5 is 5. 8 minus 3 is 5. And so your answer to this would be 55 degrees, because if you were to then turn it around the other way and say, well, 55 plus 35, it equals 90, and you would be correct. So that's how we're going to be doing complementary angles. Let's look at another example. So we got this example over here, and we have a 90-degree right angle. All right, we have angle, and this is how I'm going to say this. We have angle TRS, angle TRS, or I could say angle SRT. And this angle right here is 38 degrees. All right. But here's the thing. I do not know what angle QRT is. I need to know what QRT is for its angle. So we're going to start with 90 degrees because complementary angles are always 90 degrees. We know that angle TRS is 38 degrees. So what we need to do is just subtract 90 minus 38. All right, 0 minus 8, we cannot do that. So we're going to have to borrow from the 9 and make it an 8. Put a 1 in front of the 0 to make it a 10. And now we're set up. 10 minus 8 is 2. 8 minus 3 is 5. So angle QRT is going to be 52 degrees. All right, let's look at the next one. And that would be a supplementary angle. Now, complementary angles are based off of a 90-degree right angle. Supplementary angles, like I said, pretty easy also. A supplementary angle is based off a straight angle, and its sum, when you add it together, is 180 degrees. So if you think of S and S, all right, supplementary straight, or you can say straight supplementary. That's pretty simple. Okay, so supplementary is based off of a straight angle. So what we have down here in the bottom right hand corner of the screen is we have a straight angle, and that angle is angle BCD. Okay, angle BCD, or you could turn around and say angle DCB. All right, we know that it's worth 180 degrees altogether. Okay, so we know also that if we went from angle RCD, angle RCD, that is 130 degrees. What we don't know is angle RCB over here, angle RCB, or you can say angle BCR. Okay, so you need to find this one right here. So 180 degrees minus 130 degrees, well, 0 minus 0 is 0. 8 minus 3 is 5. 1 minus 1 is 0. So that one was pretty easy, 50 degrees. And so when you add them together, the sum comes to 180 degrees. Let's take a look at another one. I'm going to draw this straight up and down, and I'm going to, let's say that I've got angle A, B, C. And what if I say that I don't know what angle ABC is, but we do know, kind of turn your head, we do know that angle BC, angle ABD right here. I'm going to draw the little curved line with the arrow. Let's just say that that is 171 degrees. 171 degrees for angle ABD. Let's go ahead and try to find angle ABC. So we take 180 degrees because this is a straight line. It is supplementary. We subtract what we do know, which is 171 degrees. And so once you subtract that, you will find out that angle ABC is 9 degrees. So the sum of both angles would be 180 degrees. All right, the next one, like I said, a little bit harder, but there are some good ways to kind of do this. This is called a vertical angle. And what you're basically doing is in a vertical angle, you are going to take two straight lines, all right? Two straight lines or two straight angles, right? And you're going to cross them at a point. So if you look over here to the right-hand side, you're going to see these two straight lines that are crossed right in the middle. And this is going to make 4 different angles. Angle 1, 2, 3, and 4. All right. So here's the thing. Let's start out with angle 1. You know, they're giving you all 4 answers here, but all you really need is one number to actually start this out. Let's say, for instance, that angle 1 is 50 degrees. Now, over here, I kind of say catty-cornered across the street. Let's say you've got a friend that lives over here, catty-cornered. All right, for angle 3, it has to be the same number. So if angle 1 is 50 degrees, angle 3 needs to also be 50 degrees. So now you have the answer for 2 of the 4 angles. Now, it's up to you how you do this. I used to teach it where you can add both of these angles together, which would make 100. All right, the whole entire circle right here is 360 degrees. So I would say, okay, well, take 360 degrees and take away the 2 angles added together, which would be 100. And you would end up with 260 degrees left over. And then, you know, it was a little bit harder. So you would just take and divide in half 260 degrees. Well, if you take 2 divided into 260, you end up with 130 and 130. All right. But I started kind of doing it a little bit different to make it a little bit easier. And so what I did was I basically said, okay, well, we know what angle 1 is. It's 50 degrees. We know what angle 3 is. Angle 3 is 50 degrees. So if we kind of tilt our head, let's scribble out this whole bottom part down here. Okay, let's get rid of all of that. Now we're focusing on just this angle right here. Wouldn't you agree when you look at this? This is a straight angle, right? It's a supplementary angle also. It's worth 180 degrees for this, both of these parts together. It's supplementary. We know that one side is 50 degrees. We may not know what the other side is. So take 180 and subtract 180 minus 50. And that's how you end up getting 130 degrees. So if angle 2 is 130 degrees, then we know that catty-cornered across the street, the angle 4 is going to be the same exact thing as angle 2. And it's going to be 130. Now, if you was to take 130 plus 130 plus 50 and 50, it's all going to add up to 360. So there is that way you can also check your answer just to make sure that you're correct. All right. Let's go down here and get a little bit of practice. We're going to go ahead and take a look at number 3. Okay, this is backwards, but this is a complementary angle. And remember that a complementary angle is based off of a right angle, and a right angle is always 90 degrees. Now, you already know what angle OYZ is, right? Angle OYZ is 58 degrees. So what we need to do is we need to find out by subtracting that 58 from 90, we're able to tell what angle OYX is. So 0 minus 8, I can't do it. You're going to borrow from the 9, make it an 8. Put a 1 in front of that 0. Now you have 10 minus 8 is 2. 8 minus 5 is 3. So angle OYX is 32 degrees. If you take the sum of 32 plus 58, you should find that it's 90 degrees. So I want you to pause and do number 1 and 2 and find your answer. Okay, so for number 1, if you have angle DBC and it's 30 degrees, then angle ABD should be 60 degrees. Okay, so if you add the two angles together, you'll get 90 degrees. Okay, as for number 2, the answer to angle TRS, your answer should be 50, because if you find the sum of 40 degrees plus 50 degrees, that would mean angle TRS is 50 degrees. Okay, now 4 through 6 is going to be the supplementary angles because they're based off of a straight angle, right? And that is worth 180 degrees. So let's go ahead and do number 5 together, since that is a little bit more kind of strange number there for 37. Now, again, we know that all together that angle ABC is worth 180 degrees because it's a straight line or straight angle. We know that angle ABD is 37 degrees. So once we subtract 37 from 180, we will know what angle DBC is. 0 minus 7, you can't do it. Let's borrow from the 8 and make it a 7. Put a 1 in front of the 0. 10 minus 7 is 3. 7 minus 3 is 4. And then 1 minus, we can even put a 0 here if you want. 1 minus 0 is 1. So that means that angle DBC is 143 degrees. So go ahead and pause the video and go ahead and do number 4 and 6, and I will tell you what the answers are. All right, so your answer to number 4 will be 130 degrees for angle PNM, or you say it vice versa, angle MNP. Okay, once you add up 130 plus and find the sum of 50, that adds to 180 degrees. Number 6 over here, you know that angle TPQ is 140 degrees. Angles OPQ, that is a supplementary angle worth 180 degrees. So you're going to take your 180 degrees, you're going to subtract angle TPQ, which is 140. And once you do the subtraction, you will find out that angle TPO is 40 degrees. So there's your answer. All right. On down, we're going to be hitting the vertical angles now. So these are a tad bit harder, but I'm going to do 2 of them with you, and then you need to do the other one. All right. First, we'll start out with the vertical angle of number 8. Okay, so if we say that angle 2 is equivalent and is the same size as angle 4, if angle 2 is 105 degrees, that means angle 4 needs to also be 105 degrees. Okay. Now, if you want to scribble out 1/2 of this, okay, and you focus on angles 2 and 3, angles 2 and 3 right here, then you should know that this is a supplementary angle, all right, and it's worth 180 degrees. Well, angle 2 is 105 degrees. So now all you need to do is find angle 3 when you subtract these 2. 0 minus 5, we can't do it. Let's go up and borrow from the 8 and make it a 7. Put a 1 in front of the 0 to make 10. 10 minus 5 is 5. 7 minus 0 is 7. 1 minus 1 is 0. So that means that angle 3 will be 75 degrees. And if angle 1 is the same exact size as angle 3 catty-cornered, that means that angle 1 will also be 75 degrees. All right, let's go ahead and do number 9. So up here on the lines, angle 1, you're going to write 75 degrees. Angle 3, you're going to write 75 degrees. And angle 4, you'll write 105 degrees. Now, this is a much tighter kind of straight lines for the vertical angles, but angle D is 58 degrees. So straight across the street, that means that angle B has to be the same, which is 58 degrees. All right, let's focus on angle B and C. So we know that that should be 180 degrees, right? If you take angle B plus angle C, it's 180. Now, angle B is 58 degrees, so we're going to take 58 away from 180. 0 minus 8, we cannot do it. So let's borrow from the 8 and make it a 7. Put a 1 in front of the 0 to make 10. 10 minus 8 is 2. 7 minus 5 is 2. 1 minus 0 or 1 minus nothing is 1. So we have our answer of 122 degrees. All right, so that means the angle C is 122 degrees. And straight across the hall or straight across the catty corner across the street, A is the same exact answer. Now, if you take 122 plus 122 plus 58 plus 58, you should get 360 once you add all of the sums together. All right, so I'm going to have you go ahead and do number 7. Go ahead and hit the pause and find out what your answer to B, C, and D is. All right, so your answer to B will be 140 degrees. Your answer to C is exactly the same as your answer A, okay, your angle A, which is 40 degrees. And if angle B is 140 degrees, that means automatically the angle D is going to be the same answer, so 140 degrees. You'll put your little degree signs on all of these. All right, so let's see. Your answer to number 7, I said, was angle C is 40 degrees, angle B is 140, and angle D is 140. Okay, next page. Now, this is going to be where you're applying your skills, all right? It's basically working the same way as what we just did, though, okay? It's just in picture form or word form. So it makes it harder just because of that, okay? But if you have a picture, you don't really need to read the problem. You can just go off the picture, okay? So here's what it says. Practical problems involving pairs of angles often require you to find an unknown angle. Examples that frequently appear include finding an angle between a ladder and a ground, finding an angle between 2 boards or beams, finding an angle between intersecting streets, or finding a missing corner of the room angle. But in each case, you are really being asked to find the complementary angle, the supplementary angle, or even a vertical angle. So in book and on test, practical problems often appear as word problems. You may or may not be given an accompanying drawing. But in either case, the first step in solving a word problem is to represent the information in the problem by drawing that by a drawing that contains only straight lines. Then solve the straight line drawing by using the skills that you've learned. Okay, so this is nice because we have a drawing here, right? If I just look right now at this drawing, I have a brick, what looks to be like part of a brick building. Okay. And I have the ground down here. Here's the ground. I have the ladder that's leaning against the building, but it also is connected to the ground. Now, in this drawing, it's really nicely set up because if you look at this, here is the angle. Can you tell what angle this is? It's a flat, straight line. All right, so it's one flat, straight line. So that means it's either has to be a complementary, which is worth 90, a supplementary, which is worth 180, or if it's two lines crossing, it's a vertical worth altogether 360 degrees. It is a flat straight line, so this means that this is a supplementary angle worth 180 degrees. We know that the angle over here on the inside of the ladder is 61 degrees. So if we take 180 and subtract 61 degrees, 0 minus 1, we can't do that. Let's borrow from the 8 and make it a 7. We're going to put a 1 in front of the 0 to make 10. And now this is all set up for you. 10 minus 1 is 9. 7 minus 6 is 1. And 1 minus 0 or 1 minus nothing is 1. So right now it appears that it's going to be 119 degrees for this angle right here. Now, when you look at it, remember, go back to your original 5 types. Look at it, it's backwards, but it looks like almost like you're leaning back in a dentist chair. It's more than 90 because 90 would be right here. So it does appear to be about 119 degrees. It's an obtuse angle. And so that is the correct answer, 119 degrees. And if you look down here, there you go. It's 119 and it is an obtuse angle. All right, so I'm going to do about one more problem for today, and then we'll leave off right there. And then when we come back from spring break, we'll pick up right at this point where we're doing pairs of angles with drawings. Okay. All right, so let's take a look at, since verticals are a little bit harder, let's take a look at the vertical angle here for number 2. It says Ohio Street intersects 7th Street as shown below. What are the measures of the 3 unmeasured angles? So again, you could just look down here and figure it out. All right, so if this angle 1, 2, 3, that must mean this is angle 4. All right, if angle 4 is 48 degrees, that must mean straight across the street, catty-cornered, the angle 2 is going to be the same answer. So we have one of our answers already. Angle 2 is 48 degrees. So we can go ahead and write that in if you want. Now we need to figure out what angle 1 and 3 is. Well, what we could do is let's go ahead and scribble out some of this. And let's take angle 1 and angle 2 all together. We know that that is a supplementary angle and it is worth 180 degrees. So if we have 180 degrees between angle 1 and 2, but we know that angle 2 is 48 degrees, we can just use subtraction and find the answer. So go ahead and find your answer to that. All right, so your answer to this, 0 minus 8, can't do it. We're borrowing from the 8, making it a 7. We'll put our 1 in front of the 0. 10 minus 8 is 2. 7 minus 4 is 3. 1 minus nothing is 1. So that must mean that angle 1 is 132 degrees. And angle 3, which is straight across from angle 1, is exactly the same answer. Okay, so there are your answers, 132 degrees. And that should look more like a 3, of course. Okay, so what I want to do is I want to give you some homework on top of what you need to do. Again, we'll be coming back to this page right here, but I'm going to look ahead at the angle review. Okay, now this angle review is on page 30, starts on page 30. You'll definitely be able to do the whole first page, page 30. Let's go down to the second page. You should be able to do number 8, 9. And as you look at number 10 and 11, see if you can go ahead and do those too, because it's very similar to what we just did. Okay, but if you can only get down to number 9, that's fine. But see if you can do number 10 and number 11. All right, and that will be it for today. Okay, have a good day, and I will see you after spring break.